Welcome in, everybody. We are here at week 14. So we're pretty close to the final exam. The final exam is a different schedule, by the way. I'll talk about this next week. But yeah, this week we're gonna talk about something called object-oriented programming. This is it's probably gonna take like a couple days to fully cover this. There's a lot of things going on here. But yeah, object-oriented programming, there's going to be one more programming assignment. And yeah, that'll be pretty much it. Next week, we'll do a practice final. Okay, let's get started on object-oriented programming. So I have some slides set up here just to kind of visualize what's happening. Before we jump into the lesson, let's kind of give a quick overview on what this is. You can think of object-oriented programming as a technique. In particular, the technique kind of organizes functions and variables into like a singular object. So I'm gonna be using a lot of terminology, which I'll define later. Pretty much classes and objects. I'm gonna be using those two terms a lot today. But yeah, say you wanted to invent like a new variable, or maybe you wanted to write a library. Typically, you would write this in another file and then import that file into your code. But yeah, sometimes you want to invent new variables, and maybe you want that variable to have like functions attached to them. Yeah. So it's kind of good for organizing. Basically, you would invent some sort of class, and then that class would contain functions that kind of work on that class. So yeah, that's pretty much what we're talking about today. Pretty much organizing functions into a nicer interface. Let's see. Let's give a more concrete example on what object-oriented programming looks like. We've seen some classes. For example, the turtle back in like day one. So back all the way day one, we did the turtle here. This is the second notebook. So what we're actually doing is importing a turtle right here. See this first cell right here. It's actually a class that you'll see. So this import Jupyter turtle. This is a library that's written by my coworker, by the way. If you want to take a look at it, his name is Mike Matera. So I'm gonna check out his GitHub real quick, because I think he uploaded the turtle here somewhere. So let's see, is there a Jupyter turtle? Yeah, here it is. So Jupyter turtle. This is pretty much the code that runs behind the turtle. Here, let me go to source right here. Source. Okay, there is a file here called turtle.py. Let's see. So yeah, there's a lot of stuff happening here. I just want to highlight this thing right here, though. There's a class turtle. So basically, when you're using the turtle, you're really using functions that are predefined here. So yeah. Once again, I'm just bringing up my coworker's code. So whenever you import the Jupyter turtle as a you're pretty much including all of this code here, all of this stuff right here, this whole class. So yeah, if you're curious how turtle works, feel free to take a look at this. But yeah, this is like a class. So we're importing a class, and we're using it. For example, you can look at the help right here. There's a help function. So I'll say help on TU. This is gonna give me some things. You've used some of these functions before, like the move. You've used this before. So basically, when you use this move function, you're actually calling a class function. So this is a little different style right here. You see this tu.move, but basically the object is tu. So if you want to think about it for a bit, tu is an object from the class turtle. Okay. And so we're using the object and doing a move here. This is a little different, right? Because when you write functions, you typically don't really see a dot before it. You're probably used to writing functions that will be like move and then tu or 100. This is kind of like a different style because, well, first of all, this isn't gonna work. I'm basically trying to highlight the differences between class functions and classless functions. So this is a class function, the move. It's a class function because it belongs to the turtle. Okay, so yeah, we've seen object-oriented programming before, but basically today you're gonna see a lot of these periods here. This period means that the move function belongs to the turtle. So yeah, you're gonna see a lot of periods today. Okay, so we've seen some classes. We saw the turtle. There's also the string as well. This is also a class. For example, I think we've used some of these functions here. If not, I'll pull it up real quick. Let me just pull up a Python terminal. Okay, hold up 1 second. I'm just pulling up a REPL from Python terminal. Let's see, Python 3. Okay, cool. Cool, just a Python terminal. Let me zoom in a bit. Okay. We've seen strings as classes. For example, if I create a text and set it equal to like hello space world, basically, let me press enter. Text here, this is an object. It's an object from the class string. And that class string has a lot of functions attached to it. Like you could say text.upper. This is a function that belongs to a string. Basically, this function would return something. In particular, it looks like it returns the uppercase string here. So if for some reason you want to uppercase text, yeah, you could do this right here. You've also seen the split function before. Like see, so far this is what our text looks like. You've seen this text.split before. Basically, you could put in some sort of separator here. Like if I were to say split it based off of this white space, this is going to return a list. So in particular, this evaluates to the list of 2 items because this function is, yeah, it's splitting it based off white space. So yeah, we've seen strings, and there's lots of functions attached to them. You could Google this right over here, by the way. If you just Google up like Python strings, and then look at the primary documentation. So the primary documentation is right here, is docs.python. You can click over here, the string methods, and it's gonna give us a bunch of things that we've worked with. So string methods. Let's see, just kind of scrolling down. There's a lot of functions. Oh, by the way, a method is kind of like a synonym for function. So yeah, we've seen some of these functions before, like string.format. Oh yeah, you've used this before in the Mad Libs assignment. What other functions have we used? There's a lot of them. String.join. Let's see. String.split. Yeah, there's like a lot of functions here. So yeah, if you're ever curious, you could look this up. Anyways, we've seen strings. These are it's a class that contains like a bunch of functions. You've seen a list as well. a list is also a class that has a lot of functions attached to it. For example, you could do like append. Let me just make like a random to-do list. Like let me just say to-do list is equal to. I'm just gonna hard code like 3 strings here. Let me just hard code like wake up, brush teeth, and then eat food, whatever. So this is a. I'm declaring a list. I'm initializing a list. So there it is. Press enter. So our to-do list has 3 items in here. We could do a bunch of functions. You've seen the append function before. Basically, the append, you give it an element. So in this case, I'm just going to give it another string. Start driving. So basically, I'm calling a function that belongs to the list. And if I were to do this append over here, this is going to add an element to the end of the list. So our to-do list now looks like this right here. The new element is right over here. All right, people cool with this? So you kind of getting a sense on what objects are. In this case, the to-do list is the object. Okay. Whoops. Let me just. There's a lot of list functions. You can look back at the notebook. There's an insert function that takes 2 arguments. But basically, it lets you insert in the middle of the list. So if you want to, cut in line, you could use this insert function. It's pretty much saying, put an element in this position. So it's kind of shifting everything over. It's kind of like cutting in line. If you imagine it like a queue. Yeah, lots of functions, lots of them. You can look at this stuff up. You can just Google up like list Python and then check out the primary documentation. Let's see. This is not a primary documentation. This W3 schools. It's probably a good resource though. The primary documentation is right here. And yeah, there's tons of functions. There's a list.append, insert. We've seen this before. Remove. Yeah, some cool stuff. So we've seen object-oriented programming before. We saw the turtle, strings, and lists. So let's see. There's some terminology I kind of want to formalize here. Basically, there's a cookie cutter and then there's a cookie. The cookie cutter is like a class. It's like a generalization of it. This actual cookie right here is the actual object. So basically, you can make multiple objects from a single class. You know what I mean? Like with the strings example. When I said like text is equal to hello. This is, you don't really see it, but in the background, there's a cookie cutter. The cookie cutter is the string class. And the actual object here, the actual cookie is this text right here. So yeah, that's the kind of the difference between classes and objects. Basically, classes is a generalization. It pretty much defines how the object will look like. It's like a type. It's like a type. And then objects are the actual, variable name. So yeah, you've seen some of this before. You've seen some of this before. You might remember I pulled up the turtle. So it's quite a lot of code. But once again, if you were to take a look at this turtle class, this is pretty much what you're using. You're importing all of this code. So the cookie cutter lives here. There's a class turtle, and whenever you create a turtle, it's coming from this cookie cutter. So yeah, just gonna formalize these 2 terms: classes and objects. So yeah, once again, text equals hello. Text is an object that's instantiated instantiated from the class string. And then with the to-do list, we saw this as well. To-do list is a object, and then it comes from the cookie cutter list. Okay. So before we jump into the lesson, I kind of want to start off with an example. This way you can kind of see the overall goal. So I'm not even going to open up the notebooks yet. The lesson, I mean. Basically, we're going to do a quick demo. We're basically going to invent a cookie cutter that represents a card. So we're going to make a card class. That's what I'm saying. In particular, what does a cookie cutter look like? How do you represent a card? Well, we see that there's a couple attributes. There's the rank and the suit. So typically here, I need to reorder these things real quick. Okay, let me just change this over here. Yeah. So basically, a rank and a suit. So these are attributes that define what a card is. The rank is like the number. It's like a king. Here the rank is a king, and then the suit is a spade. And then maybe you can imagine there are functions attached to it, like maybe some sort of function that returns its value, maybe, and maybe some other functions. But let's start simple. Let's start simple. We're basically going to invent a card class. So check this out. Check it out. I'm gonna open up a brand new notebook over here. Let me do it in the examples directory. This is probably a good spot. So in the examples directory, I'm gonna make a notebook. I'm gonna call it, let's see, what should I call it? I'll probably call it like card class. Or I'm gonna call it deck of cards. Deck of cards. So I made a notebook called deck of cards. Basically, we're going to create a cookie cutter that represents a card, but then we're going to spawn multiple, multiple cards. So it's kind of like the cookie cutter here. We're going to make like tons of gingerbread cookies, but in this case, we're going to make tons of cards. Okay, so yeah, back to the notebook. Deck of cards, IPyNB. Okay. Wouldn't it be cool if we could, spawn a card? Like, imagine if we had this line of code here. Just if we had like C, capital C, the caps don't matter, and I just set is equal to a card. Oh, and then this parentheses here. I'll explain what this parentheses does later. But yeah, this is basically I'm attempting to create an object that's named C, and it's so here I'm attempting create an object C from the class card. So I'm attempting to do this, but it's actually going to give me a error here. It says card is not defined. This makes sense because yes, it's not defined and it doesn't exist. So the bare minimum syntax we need to make this exist is this syntax over here. I'm going to create another cell above. Let's see, or I'm just going to move this up. Move this cell up. Let me. So basically, we need this keyword class. And then after that, it's the name of the class. So I'm gonna make class card, and then you do need this colon here, because then the cookie cutter is defined in these indented blocks over here. For now, I'm just gonna keep it empty. I'm just gonna put like a doc string here, so you see what it's doing. Represents a card. There we go. So this is the bare minimal syntax we need to make a class exist. So I'll press play here. There it is. And then let me rerun this cell. Cool. No more error. So yeah, we successfully created an object C from the class card. Okay, stick with me. It's gonna make sense in a bit. This is like a blank card though. It it doesn't really have anything. Typically, cards have uh, attributes like the rank and the suit. So the cool thing about this class is you can kind of decorate it. So think of it like a cookie. A C is a cookie. You can decorate it. Like for example, maybe I wanted to put a heart. So I'll say it's suit. So basically I said C dot suit. So first of all, this doesn't even exist. if I were to print it, it's gonna give me an error. It says yeah, card has no attribute suit. So if we wanted to make it exist, you can pretty much create that decoration. You can say c.suit is equal to something. So this is like decorating the cookie. I'm gonna put a heart here. Let's see. I don't have any emoji keyboard, so I'm just gonna copy and paste it from this over here. Just gonna copy and paste this emoji. Heart suit. Okay, copy. And yeah, I'm basically representing this as a string. So yeah, I'm decorating the cookie. This is, think of it as decorating the cookie. So let me press play here. Okay, cool. So I successfully added a suit attribute, and I'm just kind of printing it out. Cards typically have a rank as well. So maybe you wanted to give it a rank. So you could say c.rank is equal to, I'm just gonna say like king of hearts. So this is adding another attribute. And then if we were to print it as well, you know, I'm gonna print it in the same string, on the same line I'm in. I'll probably do an F string, just so it looks. So I'll print out the rank and the suit. Okay, there it is. So rank, and then let me just put an of here. This way it says like rank of suit. So this is going to give us a king of hearts. Cool. People cool with this so far? All right. Here, let's do one more. So this is a cookie cutter, the class. There's actually nothing in it right now. I'm actually planning on defining some functions in here later. So yeah, stick with me. It might seem kind of weird right now. But this is a cookie cutter. So far we have one cookie and it's named C. You know, I'm gonna rename this C1 just because I'm planning on creating a C2. So I'm just gonna rename this. Yeah, so far we have one cookie named C1. You know, it's possible to make more cookies with this same exact class. We just have to do the same thing. Like if it was C2 is equal to another card, this is like spawning another card. So I could go ahead and start modifying its attributes. So I'm gonna create a suit and then create a rank. For the suit, just, I don't know, probably like a spade or something. Let me get a spade. I'm gonna copy this. Okay, boom, spade. And then the rank, I'm just gonna say like, I don't know, 6. Doesn't matter. Cool, so we're decorating the cookie. Now we have 2 cookies. So let me go ahead and print it. So print. Okay, so there we go. We printed 2 separate objects. People cool with this so far? All right. Hope this makes sense. So check this out. This part is gonna look a little weird. In practice, you wouldn't really see this style here. Pretty much the style is directly modifying the attributes. In practice, you'd see kind of a different style. Basically, you can decorate the cookie inside of the parentheses here. So imagine if I were to kind of put the heart here. So I'll put the king and then the heart here. What's up with my... So yeah, imagine this right here. Wouldn't this be a little cleaner? This is saying spawn a card named C1, but then throw these attributes in. That would be a little cleaner. This way we don't have to, set these ranks and suits. So you know what? This is actually not gonna run. We're probably gonna error out here. It's pretty much saying, yeah, card takes no arguments. But basically, with our current class, the cookie cutter, we haven't set up these arguments yet. So this is actually invoking something called the constructor or initializer. So this line right here is invoking the constructor. Same with this one. This is also invoking the constructor. So basically, we have to set up a constructor that takes 2 arguments. Okay, so this is going to look weird, but it should make sense in a bit. This is just a sneak peek. So basically, I'm going to inside of this card class, I'm going to define this constructor function, and it basically looks like 2 underscores, and then init and another 2 underscores. This is whoever invented Python decided to decided this name here. Yeah, so this is a constructor, and we need to set it up to have some arguments. In particular, 2 arguments. So the first argument would be the whatever initial rank. So I'll call it initial rank, and then the second argument represents the initial suit. Okay, and then one more thing. I'll explain this later, but basically there needs to be one more argument. The first argument represents what it's working on. So I'll explain later. But you can think of this self argument as it's referring to the actual object. But yeah, just we set up for pretty much 2 arguments here. So this, I want to document this. I'll put a document here. So this is the initializer / constructor. The goal of the initializers and the constructor is to pretty much set the attributes. Sets the attributes. So the attributes so far, there's 2 of them. There's like a suit and a rank. So basically, the goal of it is to initialize these over here. So self.rank is equal to something, and then the self.suit is equal to something. In this case, the self.rank, this is kind of referring to the actual cookie, and I'm just gonna set it here. So this is setting the attributes. Okay. So here, let me just comment some stuff out, and you'll see what I'm doing here. Okay, let me see. Let me press play here. Okay, let me run this over here. Okay, cool. So I just ran this to test the constructor. Let's trace through what's happening real quick. When we call this line, it's invoking the initializer. So it's calling this over here. It's calling this function. King is a string that goes into this initial rank variable. Heart is another string that goes into this suit. And then this self right here, this is like it's an implicit variable. Basically, this refers to the object. The object here is C1. So we're setting up this object. We're saying, hey, its self is equal to whatever we pass in as the argument. And same with the suit here. So yeah, we pretty much made a initializer. So yeah, this self.rank is pretty much like the C1.rank. It's just named self because we don't actually have the C1 name. You can name this whatever you want, by the way. You can name this whatever you want. You can name it like foo. But this wouldn't really be as readable. Yes, I'm gonna change it to self here. Okay, cool. So we invoked the constructor, which has 2 arguments, meaning that this is probably going to break right here. This line that I uncommented, it's probably going to break because because now our constructor requires 2 arguments, two more. Yeah, you see what's happening here? But basically, yeah, we have to put these things here. So go 6. There it is. Perfect. Isn't this pretty clean? So now it should run. Okay, cool. And yeah, there it is. It's printing C1.rank and then C1.suit. Okay, people cool with this so far? Okay, here, let me do one more thing. This is gonna seem unnecessary, but it's good for learning. Typically, classes have a lot of functions attached to them. So far, our class currently only has 1 member function. This is the constructor, but you can imagine other ones too. Like maybe imagine there's like imagine you could do like a C1 dot something. I'm trying to think of something right now. Let me C1 dot C1. I'm trying to think of some functions that a card can do. Let's see. Maybe you can imagine like a print function. Like imagine there's like a print function, or imagine like a display function actually. So imagine there's like a display function which pretty much prints your card out. So first of all, this is not going to compile. I mean, not compile. It's not going to run. It's saying that there's no function called display. So I'm going to go ahead and invent this function real quick. Basically, in this class over here, the cookie cutter, we would have to define another function called display. So keep in mind for the indents, by the way, the indents are very important here. If you don't indent them, then they're technically not member functions. They become like global functions instead. So yeah, make sure these are indented. So I'm gonna make a function called display. And the point of this member function is really just to print the card out. imagine like it's a print statement. So so here I'm just gonna do the print. So print. Let's see. I'll probably do an F string and keep it very similar to this. So F string something of something, and basically I'm just gonna put like a. Actually, I'm gonna get rid of this of here. Let me just print out the actual variables here. So let me go self dot rank and then self dot suit. Okay, here let me just test this real quick. So press play here. Okay, cool. I loaded in the new class, and then now let me test this right here. Okay, so I got an error here. It's a different error. It's saying that the display takes 0 arguments, but 1 was given. So this is actually kind of tricky to see. Let's see. It's saying 1. Okay, first of all, it's saying it takes 0 arguments. That means that our display function was set up for 0 arguments. But then it's saying 1 was given. There's nothing in here. There's no arguments in these parentheses. So it's actually this right here. This C1 is called a implicit argument. And basically, when we call this display function, C1 gets passed into this parentheses here. So it's kind of tricky. It's kind of tricky. So basically, you'd have to make a variable here. I'll call it self. So basically, when we call C1.display, C1 goes into self right here. Okay, cool. So let me press play here. And then let me run this cell again. Okay, sweet. So we got the display functions working. This is pretty much, yeah, it's printing the card. It's just a wrapped print statement. And you know, maybe you wanted to modify this a bit. Like maybe you wanted to print it in like a large square or something. So in that case, you could modify this print statement. I'm just gonna print some lines here. I'm not sure how to draw a box, but let me just draw a line here. Let's see. Let's go underscore underscore. Go 3 underscores, and then maybe a vertical line right here, and then another vertical line right here. Maybe a. Okay, let me just see what this looks like real quick. Okay, so now our display function. Yeah, this isn't looking right. But yeah, if you play around with the display function a bit, you could probably get it to print nicely. I'm not really an artist, but yeah, you can just fix these print statements, and yeah, and these will look a little nicer. Let me see. Is there a quick fix I can do? Yeah, there's probably a quick fix because this is kind of bugging me. Let me put like a vertical line there, and then let me add another underscore. Okay, looking a little better. And then vertical line there. Okay, cool. Yeah, so you can just play around with it and kind of mess with it. So yeah, people, any questions about this so far? This is just an example, by the way. We'll jump into the lesson and things will kind of make a little more sense. Any questions on this class card? Okay, cool. Yeah, so we just did a quick demo, kind of giving a sneak peek. So yeah, that's classes and objects. You know, let's jump into the lesson now. So I'm gonna go ahead and open it up. Oh, you know what? Hold up, not yet. Let's do some cool stuff, actually. Let's do some cool stuff. With this cookie cutter, we can create a whole deck. Currently, it would be kind of tedious. There are, like, 52 cards in a standard deck. So it would be kind of tedious to kind of do this over and over again. You see what I mean? You have to do this like 52 times. Wouldn't it be cool if we could, represent a data structure, like a list? Maybe we could create a deck. So I'm gonna do another cell here. Basically, just gonna create a deck of cards. I'm gonna represent it as a list. So, whoops, let me delete this. So yeah, I'm trying to represent a deck, and it's going to be a list of objects. So this is going to be a list of objects. In particular, card objects. So it's empty right now. You could hard code a bunch of things. Like you could say that this is the first card, and then this is the second card here. This does work. It does work. This is now a list of 2 elements. So you could say deck 0 dot display. Deck 0 dot display. It's saying grab the first card and display it. So yeah, this does work. And then 1 dot display. But there's some cleaner methods. Basically, you can write a loop that goes through all of the possible combinations, and then kind of build the deck one by one. So this is going to look kind of weird here, actually. I'm going to go ahead and declare all of the possible suits, possible ranks and suits. And this is going to be good for learning purposes, actually. So the possible ranks, this is going to be a list of 13 things. But basically a deck of cards is 13 times 4. And if you're not sure why, it's basically because there's 13 ranks. Let me pull up a better picture. Yeah, basically 13 times 4. There's 13 ranks, and then there's 4 suits. So I'm basically trying to represent all the possibilities. There's 13 ranks, and then 4 suits. So the suits, there's going to be 4 items in here. I'm just going to hard code in. I mean, not hard code. I'm going to put in the emojis here. So there's a heart. There's a heart. There's a diamonds. I need to copy and paste a diamond. If you have a MacBook, you could probably have an emoji keyboard or something. Let's see, spades, and then clovers. Clubs, I mean. There's the clubs. Great. So there's all the possible suits, and then all the possible ranks. I'm just gonna put in a bunch of strings here. Basically, this is like, ace, 2, 3, 4, 5. I'm representing them as strings because there's face cards like ace, jack, king, and queen. So jack, queen, and then king. So I think this is 13. Let me just double check real quick. It's always good to sanity check. So, I mean, I could just count it right here, but possible ranks and then possible suits. So this should print 13 by 4. Oops, made a typo here. 13 by 4. Okay, cool. So it's looking good. If we wanted to construct a deck, basically we could create all of the possible combinations. This is like multiplication. You know what I mean? Like 13 times 4. So you'd have to kind of go through all the combinations, like ace of hearts, and then ace of diamonds, and then ace of spades, and then ace of clovers. And it's the same with all of these other ones. You could go 2 of hearts, 2 of diamond, 2 of this. So yeah, people kind of seeing what I mean by the multiplication by 13 times 4. So yeah, you could actually write a loop that goes through all of these. Well, one way you could do it is kind of with a nested loop. So you could say for all of the ranks, or for rank in possible ranks, this is saying go through this array. I mean a list. And then maybe for each of these ranks, we could go through all of these suits. So there's going to be some nesting here. For suits in possible suits. All right, people see what's happening here. Basically, it's saying for every rank, but then every rank is going to go through every suit. So that's kind of what's happening here. It's going A, all of these, 2, all of these, 3, all of these. That's pretty much what this for loop is representing. And so this is doing like a 13 by 4 iteration where the inner loop is happening 4 times and the outer loop is happening 13. So here you just have to create a card. So I'm gonna say I'm just gonna say C. C is equal to I'm gonna go ahead and invoke the constructor. The constructor currently takes 2 arguments. It takes the rank and suit. So there it is. This is creating a card, and now all we have to do is append it to the deck. So deck is a list that has a member function called append. So I'm going to append C here. So C represents everything. And here, let me just verify. Let me just run it. Okay, it ran. There's no output, but let me sanity check. The length of the deck should be 52. Okay, cool. So it is 52. It's a correct size. Maybe we could go ahead and iterate through it. So let me just iterate through the deck and kind of display everything. So you could write another loop that displays everything. So I'll say for I'll call it single card in deck. So basically deck is a list of card objects right here. And this single card here kind of represents, yeah, a single card. So I'm just going to go through all of it and maybe just display it. So you could go single card dot display. Okay, let's test this over here. So press play. And yeah, it's looking good. So it kind of, there's a lot of output. Yeah, people kind of seeing what happened. We have a data structure called deck. It contains every possible combination. So we got ace of hearts, ace of diamonds, and all of this stuff over here. Pretty sick, right? Okay. Hold on, let me get rid of this 1 underscore over here. So this print, I don't think I need this underscore. I have a tiny bit of OCD. Bro, what's up with this? Oh, you know what? It's probably because the emoji. The emojis will kind of mess up the width. So yeah. Okay. Anyways, yeah, people see what's happening, right? Pretty sick, pretty sick. Okay. Any questions about this so far? So, you know, with this deck, you could do a lot of things. you could probably write a whole casino game now. You could write a blackjack that kind of runs in a infinite while loop. Okay, so yeah, that's about it for this card example. So yeah, in summary, we really just made a cookie cutter called card, and we kind of just created some cookies here. In this first example, we created 2 cookies, and then in this next example, we created 52 cookies. Okay, people cool with this so far? Any questions? Okay, cool. Let's move on. Let me pull up the lesson. So I'm gonna save this notebook, and here we go. The last lesson. People excited? Last lesson's right here, number 20. What's up with these right here? I'll probably delete them later. Okay, last one, classes and objects. Here we are. Hold up, let me grab some water. Okay, how are people doing so far? Okay, cool. Yeah, hopefully people are seeing what classes are. Let's see. Let's start off with a simple class. This is kind of what we did earlier. So this is just a simple class. It doesn't have any attributes yet. I guess I'll put a doc string in here. Okay, so there we go. We just created a cookie cutter that's named simple. It's got nothing in it yet, but you could create cookies from this cutter. Like, you could create something called like instance. I'll call it instance. And yeah, this. Let me document what's happening here. Instance is an object from the class simple. Okay. Well, let me run this. There we go. We have successfully created an object. You can look at the docstring of certain classes, by the way. Currently, this class just has like a very small docstring, and if you wanted to print it, you could look at it right here. So the help function pretty much prints out the docstrings. Run this, and yeah, there's a docstring right here. My simple class. It's saying that there's some functions here. You don't have to worry about these. These are pretty much inherited functions. I'm not really going to talk about inheritance today. Probably not in this course actually. But yeah, the later part of this notebook talks about inheritance. This is kind of some tricky stuff, and I don't expect folks to fully master this stuff. So I'm actually going to skip inheritance. I'll talk about that later. Anyways, don't worry about these things right here. They're like inherited things. But basically, things in Python are, it's kind of like there's a parent class, and then there's the children class. So sometimes the children would rely on the parent. And in this case, these were inherited from the parent. The simple is a child class. All right, cool. So we're just kind of playing around with this simple class. Currently it's empty. So if I were to create another cookie, and I'm just gonna name it 1. You can call it whatever you want. So 1 is now an object, and if you wanted to decorate the cookie, you could decorate it by saying, 1.name is equal to something. I'll name it Andrew here. And then I'll say the job here is instructor. So this is pretty much like decorating the cookie. In practice, this is kind of not really done. I I think in standard practice, there's you want to define like an initializer. So you've seen that in the deck of cards. Basically, this is going to build up. I'm basically going to make like a initializer function later, which pretty much does this in a kind of a better style. Like basically, we'd be able to say, you know, Andrew here and then instructor here. So I'll do this later, but I'm gonna stick with this simple one first. So I'm decorating the cookie, and then maybe you wanted to create another cookie, like 2 is equal to simple, and then maybe I'll say 2's name is equal to I'll say like Jim here. Let's say Jim, and then maybe Jim's job is for some reason like a radio engineer. I'm just making some stuff up. This is just like a random thing I thought of. So press play here. Now we have 2 objects, and we can, you know, we can print those. We can print those things. Yeah, we could print their attributes. 1.name and 2.name. Okay, cool. Yeah, no surprises here. Andrew, Jim, and then if you wanted to print out the job, you could do that as well. Okay. Cool. Here we have something called a global function. This is not a class function because it's not inside of the class. So we're gonna see 2 different styles. This is a global function right here. Basically, it takes an object as an argument. So here, let me document this real quick. So this is it's just a print function. That's all it is. It prints the attributes in a simple object. It's this is a global function, by the way. This is a global function. It's not a member function. So I'll talk about what this means later. But basically, it's a global function, meaning that we call it plainly. We don't use a period. We would just say print stuff in simple. And then in this case, I'm going to put 1 and then 2 here. These are predefined, by the way. If you scroll up a bit, I did define these 1s and 2s. These are cookies, once again. Just to scroll up a bit. 1 and 2 are initialized here. So down here, I'm pretty much printing 1 and 2. And in this case, here, let me print out some equal signs here. Print out like 40 of them. Cool. So this is a global function. 1 gets passed into this variable called instance. So we're just kind of putting the stuff in there. Later on, we'll see a different style here. The style we'll see is kind of like a member function. So in the future, we'll see like 1.print stuff. 1.print stuff. It's probably better to name it like display. And then over here, we'll do a 2.print stuff. So this is like a different style. Unfortunately, this style is not going to work yet because we have no member function named print stuff. Currently, once again, our our class is defined all the way up here, and no it has no functions yet. So we're actually going to build upon this in just a bit. I'm going to copy and paste this. I'm going to copy and paste it later because we're going to upgrade that function. So yeah, but real quick, this is invoking the kind of like a global function, and then this one is attempting to invoke the member function, which we don't have. We don't have this yet. So we're gonna go ahead and define this. Actually, yeah. So down here, let's go ahead and do that. So let's go ahead and redesign this simple class. So I'm gonna go ahead and redesign it. So class simple, and this is a somewhat less simple class. So I'm gonna go ahead and make a display function here. So imagine that there's like a function called print stuff, and then I'll explain what this self variable is in just a bit. I'm just gonna go ahead and print some things. So name is, I'll do it like an F string actually. Name is self.name, and then job is the self.job. Okay, so here is our display function, and the cool thing about this is we can use the member function now. So if I were to make another cell here, I could say one.printStuff. This is invoking the member function. It's not invoking the global one, so it's calling this one over here, and we could say one.printStuff. Let's see. I think I made a mistake here. Simple object has no attribute. Print stuff. Oh, you know why? So this is kind of tricky to see. I do have the attribute print stuff, but basically this one right here is referring to a old class. This is referring to the previous class that has nothing here. So I need to re-initialize these variables, objects I mean. So I'm gonna go ahead and copy this, and then let me recreate the objects. So here we go. I just recreated two objects, and it's coming from this updated simple class. All right, so let me press play here. Cool. So this is the member function, one.printStuff, and then we could go two.printStuff. Let me print some equal signs here. There we go. See, so now we successfully invoked the member functions. This is a different style. It's a different style from these this global function above. So yeah, you see what I mean by the differences. This is a global function because it's not inside the class. So when we invoke it, we don't do like a period. But then when we upgraded the class and put a member function in here, we would invoke it with this dot here. Okay, people cool with this so far? Okay, cool. Let's see. Yeah, we just did this over here, so you could do it again if you want. I'll create an instance from the simple class, and then I'm just gonna set the name here. Goes Andrew again. Instance, and then if I were to print the stuff, it's gonna give me an error. It's pointing at job, but basically the member function says, hey, this doesn't exist. And yeah, that makes sense because I never initialized the job here. So I'll say my job is instructor. And then that should get rid of the error. There it is. So yeah, it's the same thing. So yeah, understanding the self variable, let's kind of trace through what's happening. Basically, this self variable is like it's like an implicit argument. You don't really see it. So self is an implicit argument. It's one of the things with member functions. When we called one.print stuff, well, one is the implicit argument that this is the name of the object. So one actually gets passed into this self here. So self is referring to one here. And then when we call two.print stuff, self is now referring to two. So that's kind of the tricky part here, just understanding this self variable right over here. Yeah, so this diagram kind of explains this. You don't have to call it self, by the way. Once again, it's just for readability. you could call it foo if you want. You could call it foo. And so now, yeah, see, it does the same thing here. One gets sent into foo, two gets sent into foo. So yeah, implicit arguments. I'm gonna name it self though. This is standard convention. Okay, cool. Let me scroll down a bit. Yeah, understanding the self variable. Okay. Any questions about this so far? Okay, cool. What's happening here? Let's see. Oh, looks like here we're spawning. Yeah, we already did this over here. So I'm gonna scroll down. Let's add one more function and we'll pretty much be almost done. Let's go ahead and redesign this simple class and add a function that prompts the user for some sort of name. So let me go ahead and redesign this. So a class simple, and there's going to be a print stuff. You know, I'm just going to copy this over. I'm going to copy this previous one. But basically, we're going to take this and add another member function. Okay, let me see. Okay, so this is our current one. We're going to add another function. But basically, this next member function lets you type in your name. So ask the user for the name. Let me go ahead and define a function called input name. And then it's going to take an implicit argument, self, and then another argument, the prompt. Basically, this second argument represents what the user will see. So if I were to take input with some prompt, this function is going to wait for the user to type. And when the user types something and presses enter, it's going to return a value. I'm going to store this value into a variable called self.name. Okay, cool. Let me go ahead and run this real quick. So there it is. We have a new class, and let me go ahead and invoke it. So if I were to invoke it real quick, like say I'll say someone is equal to simple. This is now a cookie. If we were to try to print the stuff, someone.print stuff, this is going to give us an error message because the name never got initialized. You could initialize the name manually, like by saying someone.name is equal to something. This would solve this error message, but we did write a function here that will initialize the name for us. So you could say someone dot input name, and this is going to call this function. Oh, I forgot an argument here. This function takes an additional argument called prompt. So once again, someone gets passed into self here, and then this prompt, this is like a string. So you could put in like a type your name, and this string will get sent up into this input function over here. So let me run this. Okay, so I just ran it. The cell is still running, by the way. Basically, we're stuck inside of this input function. The program is waiting for us to type something. So I'll type in Andrew. And then the second I press enter, this function will finish and return a string. That string will be stored into this self.name. So the print function should no longer error out right here. The name will get initialized here. So let me press Andrew and then enter. Okay, cool. So we did not get an error message here anymore. It's pointing at job. So yeah, this also makes sense. Basically, the job was never initialized. So if you wanted to initialize it, you could do it manually. I'm just gonna hard code it in here real quick. I'm just gonna say hard job is equal to instructor here. So this is just hard coding it. It would probably be better to make another function called input job. So I'll say type your name, Andrew, and then enter. And then yeah, so I successfully got this name. And I did hard code this instructor here. A better programming practice would maybe be to define a function. So I'm going to define a function called input job self and then prompt. And same thing, equals to the prompt here. So instead of hard coding here, you can say input job and say what do you do for a living? What do you do for a living? Let me just change this over here. What's your name? So just kind of two questions here. These are prompts. And then let me play this. Okay, cool. So we are stuck inside of this input name function, waiting for name. So I'll press enter here. Enter. And oh, I got an error message here. It's saying simple object has no attribute input job. Oh, I never have to rerun this cell over here because I updated the class, so I gotta reload it. Okay, let me reload this. Okay, cool. Andrew, enter. Cool. So I finished this, and then now, what do you do for a living? So I'm an instructor. And then when I press enter, this is gonna finish, and we'll print the stuff. So let me press enter. Boom, enter. And yeah, name is Andrew, job is instructor. Cool, cool. People cool with this so far. These are called member functions. If you're gonna jump into programming, these are technically called these are mutators or set functions. But basically, a mutator is a function that sets variables. In this case, these two are setting the attributes, the name and the job here. All right, people cool with this so far? Okay. Great, great. One more thing. There's a constructor that we kind of talked about in the deck of cards. Basically when we here, let me copy this over here. So this is our current class. So far when we create a cookie, we would say someone is equal to simple. So this is us creating a cookie. This is actually this on the right side of this. This is invoking the constructor or initializer. We actually don't have an initializer in the function, meaning that nothing really happens. we just create an object. But sometimes it's necessary to create objects with custom attributes. Like maybe I wanted to say, hey, someone has 2 attributes, and maybe I'll say, you know, Andrew and then instructor here. So you see what I'm trying to do here? It's kind of like the deck of cards. Earlier in the beginning of this lecture here, it's we're trying to do something like this here. We're trying to spawn a card, have 2 attributes. So that's what we're trying to do. So this is invoking the initializer. In this case, we don't have an initializer, and the default initializer takes no arguments. So we could create a constructor here. So the constructor in Python, it's named underscore underscore init and another underscore underscore. And then there's one variable here. I'll call it self. Basically, self refers to the object that you're calling it with. So when we called this line here, someone is equal to simple, someone gets passed into this self variable. So inside of this function, there are 2 more arguments, by the way. There's the initial job, initial name, I mean, and then the initial job. So basically, these 2 variables, these 2 strings, get sent up into these 2 variables here, and you could use those to initialize the name and job. So yeah, I'll initialize it to initial name and then initial job. Cool. So let me reload this class. So press play. And then I'll also run this over here. So we should no longer get an error. Cool. Oh, so we successfully invoked this constructor here, meaning we could print stuff. We could say someone dot print stuff. And yeah, it's just printing my stuff out here. Yeah. So people see what I mean by constructor. It's just initializing its attributes. In this case, the simple class has 2 attributes, self name and then self job. So yeah, let me just comment this real quick. This is the initializer constructor, which pretty much sets the values, sets the attributes. Okay, cool. So yeah, here it is. And maybe if for some reason you change your name, let's say I changed my name in the future, you have to do like a input name here. This is a mutator. The mutator will change the attribute. So here I'm going to give it a prompt, because someone, this is a implicit argument that gets sent into self, and then we need another argument. Basically, this is the prompt. What's your name? So let me test this. Okay, cool. So I have someone. It started with Andrew, instructor, and maybe for some reason I wanted to change my name. So I'm just going to change my name to Tack here, and then enter, and then now we see that we mutated something. We mutated the name here. All right, people cool with this so far? Okay. Cool, cool. So yeah, that's pretty much what the init function is. It's like a constructor. Hold up, I need to reload this notebook. Something is glitching here. So let me save this and reload. Refresh. Okay, cool. Yeah, so we just finished talking about the init member function. Okay, cool. So that's pretty much it for this notebook. I'm gonna skip over some things. Blog entry. I'm probably not gonna talk about this until the next class meeting, because it's the next assignment will kind of use this. So when I introduce the next assignment, I'll go back over this blog entry thing. But I'm gonna skip over this later part of the notebook. This later part of the notebook talks about inheritance. I'm not expecting folks to dive too much into here. It's kind of a deep rabbit hole, but basically, sometimes classes would have parents. Like you could think of, maybe you created like a class animal, and then you'll create more classes like a cat or a dog, and basically those would inherit from the parent class. So yeah, I'm gonna skip over inheritance. It's basically saying that you can create classes that depend on another class. Like here we have the parent class called base, and then maybe you wanted to create another class that inherits from the base. So this is inheritance right here. This is the parent class, and then this is the child class. The child class inherits from the parent. So yeah, I'm not gonna jump into inheritance too much, but if you go into the next class, the next Python programming class, there's gonna be some inheritance in there. Okay, cool. So let's kind of summarize what we did so far. We talked about object-oriented programming. We've used it as a way of kind of organizing code. We invented a card class and defined some functions into it. So this is a different technique. It's arguably like a cleaner technique because your code can come out looking very clean if you kind of organize things in classes. Like this deck of cards over here. Back in the beginning of this class, we defined a new variable or a class. So yeah, we invented a variable, and you see how things are kind of super clean. The style of object-oriented programming is like a bunch of dot functions, and the functions are kind of hidden away. Well, they're not really hidden; they're like in plain sight right here. But you know, for the turtle. The turtle back all the way in lesson 2. This was kind of clean code here. Let me clean this, clear this cell. You see how clean this is? You would just say tu.move, and you don't really have to worry about what's underneath the move. If you did want to look at it, it's in the library here. So there's a library called Jupyter Turtle. This is pretty much like another file that contains a class. Once again, this was written by my coworker Mike Matera. He stored his Mike Matera right here. He's an instructor at Cabrillo. Let's see. He wrote this library over here. It's called Jupyter Turtle. And basically, when you're importing the turtle, you're really just including this class over here. There's this class called turtle.py, and it's some Python code. Basically, in order to draw the turtle, it relies on a bunch of other libraries, like a library that deals with colors, a library that deals with math, and but basically you're using class functions. So the turtle is a class, and to you, this is like an object. So we're pretty much spawning an object here, and the object has member functions. It's got a initializer. It's got a bunch of other functions here, like a move. Where's the move function? Yeah. So you see this move function, but basically whenever you call this move member function, you're really invoking this code over here. This is a code that pretty much uses other libraries to calculate the things in the coordinate system. This is really what the move function is doing. It's so hopefully people are seeing what object-oriented programming is kind of. It can look super clean, just hiding stuff away. Okay. We've seen a lot of objects. We've seen the card class. We've seen the turtle. We've seen strings. These are also objects. I mean classes. Lists are also classes. Dictionaries are also classes as well. We've seen a lot of them. So hopefully this makes sense what a cookie cutter is now. Basically, a class is like the cookie cutter. It defines what the object will look like, and you can create a bunch of cookies with it. Those cookies are called objects. You can create a bunch of them. So yeah, hopefully that makes sense so far. With object-oriented programming, so far we've kind of done like really small examples, like a card class. Basically, there's this. We defined a card to represent just two variables. That's really all we did. But there's some other practices as well. In the lab, you'll see like a counter class. So in the lab, you'll see this class over here. It's pretty much gonna ask you to create a class that represents this tally over here. If you ever played around with this tally, basically there's a couple buttons. There's like this button on top will increment. So if you press it, it's going to increase the number. And then there's like a reset button. It's not really a button, it's like a knob, but you can think of it as like a button. And if you press this button, it's going to reset everything to 0. The lab is really gonna ask you to implement this over here. But basically each of these objects have a member variable called count, and then there's some buttons attached to it. These buttons will pretty much modify the member variables. So yeah, you'll see this in the lab. Let's see. Typically, I do a demo called the player class. I'm not going to do this, but you can make like a whole RPG game if you wanted to. Basically, you define a player class, and the player class would have attributes like these bars over here: health, mana, stamina. And maybe they'll have like some sort of data structure to represent what's in the inventory. So yeah, if you were to define a player class, you could probably write like an RPG game. That's about it for today. Hopefully people are cool with this. Next class, we're going to introduce the next assignment. I haven't really published it yet, but you'll see it in a couple days. It's pretty much the last assignment is going to be representing a Wikipedia class. So it's going to rely on stuff from last week as well. Last week we talked about data structures, and we talked about going through a web API. In particular, we used the Wikipedia API. So yeah, our last assignment will be using a class. We'll be implementing a class that interacts with Wikipedia for us. So yeah, pretty cool stuff. Okay, yeah, that's about it for today, folks. Hope people found this pretty cool. This is object-oriented programming. Yeah, some good stuff. Okay, thank you all, and have a great day, everybody. Great night.
Thank you. Happy Thanksgiving.
Yep, you too, Jim. Happy Turkey Day. Or not yet, almost.
Close.
Yep.
Good night.
Good night.